Will doomsday reach us earlier than we all expect because of recent evidence that the Earth is cooling down too fast? Well, believe it or not, the latter half of the statement is very true, but let us see what the trouble that we would have to face actually are. So what is the actual problem if the core of the Earth cools faster than we expected? For that, let's talk about the blue planet as a whole. The crust, mantle, and core are the three layers that make up the Earth's interior. The crust is the Earth's uppermost layer, and the core, located at a depth of 2,900 kilometers, is the Earth's innermost layer. The crust is the Earth's outer layer, or surface, where we dwell. In comparison to other layers, the Earth's crust is a thin layer. The Earth's crust is around 5 kilometers thick in the ocean bed and nearly 70 kilometers thick on the continents. The crust layer of the land or continents is made up of silica and alumina, which is why it's called Sial. The mantle is the next layer under the Earth's crust. When compared to the Earth's crust, this layer is quite thick, measuring around 3,000 kilometers in depth. The mantle layer is made up of various silicate rocks that are high in magnesium and iron. Generally, on all planets, mantles are the largest and the most substantial layer of the planetary body and are composed of rock or ice. Mantles are found on planetary bodies that have experienced density differentiation. And finally, at the heart of it all, we have the core of the Earth, and here is a quick summary of it. As we all know, we humans live on the crust, which is the small topmost part layer of the Earth. Inside the crust lie the mantle and the core. The core is the central sphere you see in the middle of the Earth. Now, the Earth's core is said to be really hot. It's hotter than the outer layer of the Sun. The Sun is around 5,500 degrees Celsius, and the Earth's core is about 6,100 degrees Celsius. That's about 600 degrees hotter than the surface of the Sun, meaning that an object would last considerably longer if it was blasted off into the Sun than if it was shot down to the core of the Earth. Moreover, there are actually two parts to the core, the inner core and the outer core. The inner core is about 1,500 miles or 2,414 kilometers thick. Both the inner and outer cores consist primarily of iron and nickel. They're extremely hot, with temperatures ranging from 7,200 to 9,000 Fahrenheit or 4,000 to 500 degrees Celsius. The inner core is under intense pressure, which keeps it solid despite high temperatures. The outer core, which is liquid, is about 1,300 miles or 2,920 kilometers thick. Researchers say the core of the Earth is cooling at a faster rate than previously assumed, which might hasten the world's inevitable path toward inhabitability in millions or billions of years from now. The planet's interior has been steadily cooling for its entire 4.5 billion year history, which has been a generally beneficial pattern as it evolved into its current green paradise, where people have lived for the past 200,000 years or so. A group of scientists studied bridgmanite, a common conductive mineral that is found between the Earth's core and mantle. They found that it's 1.5 times more conductive than previously believed, meaning Earth's cooling process might also be faster than previously thought. The researchers said, "We found the bulk thermal conductivity at the core-mantle boundary becomes 1.5 times higher than the conventionally assumed value, which supports higher heat flow from the core, hence more vigorous mantle convection than expected." They continue to write, "Results suggest the mantle is more efficiently cooled, which would ultimately weaken many tectonic activities driven by mantle convection more rapidly than expected from conventionally believed thermal conduction behavior." What problems does the Earth's cooling down faster than we thought cause? Well, for starters, when the planet goes cold, it'll lose its magnetic field. This is because as the planet spins, the two parts of the core, the inner solid core and the outer liquid core, move at different speeds, generating electric currents. Those currents generate our geomagnetic field. If the Earth's core cooled down, it wouldn't produce any currents. The Earth would lose its magnetic field, which shields the Earth from harmful cosmic radiation, and thus, a larger number of charged solar particles would bombard the planet, putting power grids and satellites on the fritz, and increasing human exposure to higher levels of cancer-causing ultraviolet radiation. Also, birds will not know where to fly when they migrate, and compasses will stop pointing north. This is because, again, there is no magnetic field, and thereby no way for the compass to know and indicate the direction, rendering it useless for travellers and people travelling via ships and so on. The magnetic field has switched in the past, switching north and south. The most recent of these reversals occurred roughly 780,000 years ago, during the time of Homo erecticus. The weakening of the magnetic field has usually preceded past flinches, prompting concerns about whether another one is on the way as a result of the very same cooling down of the Earth's core. However, the field might diminish and then strengthen without flipping, a phenomenon known as excursion. This basically means that there would be no atmosphere, as the atmosphere and oceans would get blasted away by the radiation of charged particles from the sun. This would make it so that the air would be too thin to breathe, and the Earth's surface would be chilled due to a lack of atmosphere. The temperature would drop below freezing, but not to the point of being dangerously cold. Ocean water vapor would operate as a greenhouse gas, alleviating global temperatures. A magnetic field isn't required for having an atmosphere. Venus has none but a vast, if unwelcoming, atmosphere, but it does operate as an extra layer of protection. Mars's atmosphere has been stripped nearly entirely away, despite the fact that it once possessed a magnetic field that was destroyed 4 billion years ago. And even if it were possible to provide the Moon with an Earth-like atmosphere, the solar wind would vaporize it in a century. This would mean that you wouldn't be able to breathe without a pressure suit and an oxygen mask, so no breathing exercises would help you relax. The Earth would become increasingly frigid as the frozen core failed to heat up rocks, water, gas, and other geological stuff. Also, sadly, auroras will disappear, as they are formed due to the interaction between Earth's magnetic field and particles of solar wind. The only good thing you could get from this is that volcanoes, on the other hand, would no longer erupt with lava. Continents would cease to drift apart, and earthquakes would cease to exist. Nobody could stay on that planet for very long. At that point, the Earth would become a sterile, uninhabitable rock. However, it would be a good simulation of life on Mars. As the plates move, they will unavoidably collide with one another. The Himalayas are a result of the Indian plate colliding with the Eurasian plate to the north, causing the crust to buckle and form mountain ranges. Along the line where one plate dives under another and raises it up, mountains and volcanoes form. Deep trenches from where two plates move away from each other, with mountains and volcanoes sprinkled along the seam. Faults arise when plates move past one another along a boundary, causing large earthquakes on occasion. The San Andreas Fault in California is an example. So, if the Earth's core does cool down completely, you can say goodbye to all the things we've just mentioned. However, another interesting point to note is that even after the cooling down of the core, travelling to it would still be an impossible task. Even if the Earth's core had lost all of its heat, the pressure would still be 3.5 million times higher than on the surface. Anyone who even comes close to the exact midpoint from the North Pole to the South Pole would be squished into the planet, literally engulfed by it. Well, that's all we have in store for our video today. I hope you learned something new today, and if you like this video, leave a like, subscribe, and turn on post notifications so that you don't miss out on great content. Of course, check the channel out for more amazing videos just like this one. But until then, we'll see you all next time. Goodbye.